For this first example, we're going to go through and find the value, an exact value for the cosine of 112.5 degrees. Now this angle is not one of our special triangle angles. It's also not one that we could find using really any of our formulas up until this point. However, we can use a half angle identity to find the cosine of 112.5 because 112.5 is half of a 225 degree angle. And a 225 degree angle can be found using our special triangles. Okay, so remember that if you take 112.5, double it, you get 225. And 225 is a 45 degree angle in the third quadrant, right? It's 180 degrees plus another 45. So that's 225 degrees, which is a 45 degree angle in the fourth quadrant. So we can use a 45, 45, 90 triangle, which we know has sides 1, 1, and root 2, or ratios 1, 1, and root 2. And we can use that information then, and also the idea that the cosine is negative in the third quadrant, right? ASTC, T is positive, cosine, so tangent's positive, cosine, sine are negative in the third quadrant. So all that information together, or let's see, oh, also, hold on a minute, I should put not x there, cosine of 225 is in the third quadrant. However, the cosine of 112.5 is in the second quadrant, right? 112.5 is up in here somewhere. So because that's a second quadrant angle, so cosine, so sine is positive, so cosine is still negative here as well. So the cosine of 112.5 must also be negative because it's in the second quadrant. 112.5 is in the second quadrant. So now I'm going to look at, because I'm looking to find the cosine, I look at my formulas and here's the cosine. So I'm going to plug stuff into here. So that means the cosine of 112.5 degrees must be equivalent to plus or minus the square root of 1 plus the cosine. Now if this is half the angle, then here I've got to put the full angle, which would be 225, all over 2. Now I need to know the quadrants of both A and A over 2, right? So the quadrant of A and the quadrant of A over 2. The cosine of 225, I said was negative, so this value here is negative, and the cosine is root 2 over 2, right? 1 over root 2, or rationalizes root 2 over 2. So this becomes, how do I write this? The square root of 1 plus root 2 over 2 all over 2. Right, so my cosine, oh, but it's negative. So I need a negative in there. Sorry, I missed that. So cosine 225 is negative root 2 over 2. Oh, and then I also need to know, because the cosine of 121 or 112.5 is negative, I want to select the negative value, so we'll ignore the positive there. Now I just simplify. Now this thing is not easy to simplify, but we can get there. What you want to do is isolate the numerator, get that to be a fraction, and then divide it by 2. So I'll take that off to the side. Think about 1 minus root 2 over 2. To get an LCD, I've got to change the 1 into 2 over 2. Right, so it's 2 over 2 minus root 2 over 2, which is 2 minus root 2 all over 2. Okay, as one fraction. So that goes on top, and then I divide that by 2. So it's negative square root of 2 minus root 2 all over 2 all over 2. That makes sense, hopefully. So I got a fraction on top with a 2 on the bottom. Now, when I divide a fraction by 2, it's like doubling the denominator, right? You multiply by the reciprocal, which puts that 2 on the bottom. So, equivalently, I could write this as negative square root of the numerator with a extra factor of 2 on the bottom. So it'd be 2 minus root 2 all over 4. Okay, hopefully that makes sense, because when you take a fraction and divide by 2, you're doubling its denominator. Well, this square root splits to the top and the bottom is nice because it's now a perfect square. So I can actually write this as negative square root of 2 minus root 2, and the denominator, when I take the square root of 4, is just 2. And now the root doesn't extend to the bottom, it just stays on top. Okay? So this value here should match the cosine of 112.5 degrees. This would be an exact value because it involves all roots, there's no decimals involved. And if I grab my calculator, which is in my bag, I can verify this to you using the decimal expansion. Let's go to my degree mode, make sure we're in degree mode. And if I calculate the cosine of 112.5, I get a decimal, and then I'll type this guy in. Now this guy here, I put negative, a root, I'll show you this in just a moment, a root of 2 minus another root of 2, all divided by 2. Okay, so whoops, not bump the table there. All right, hopefully you can see that and it comes in clearly. Cosine with the angle is a negative roughly 0.38, what's that, 2? I'm reading it backward on the screen. And if I do the expression we just found with the 2 minus root 2 all under a root, and then divide that by 2, I get the exact same decimal. Okay, so that verifies it, hopefully, that those are the same thing. We can do a similar process now for any angle. What's kind of interesting is I can kind of nest these things. I can repeatedly apply these formulas. And so, give you an example of that. If I know that the cosine of 112.5 is negative square root of 2 minus root 2 all over 2, that's an exact value, then I can take this and find the cosine of half of that angle. What's half of 112.5? 56.25, right? Double check. 56.25. So if I find the cosine 56.25 degrees, that again is going to be found using my half angle formula. 56.25 is a first quadrant angle, so it's going to be positive. We would select the positive option. And then under the root, I'd have 1 plus the cosine of A. Well, the cosine of A, that's the original angle, which is this thing. So it'd be a negative root of 2 minus root 2 all over 2, and then all over that 2. And you can see how you can start to nest these one inside the other as you cut them in half, okay? This really gives us the opportunity to find a slew of angles, right? Exact values for many different angles. Now, this is going to get weird because you're going to have roots inside of roots inside of roots, but it still works, okay? It's a nice exact value. And you could simplify this further. You would end up, I think, I'm just kind of running through this in my head, 2 minus the square root of 2 minus the square root of 2 all over 4, which should end up being the square root of 2 minus, make that root just on top. 2 minus root of 2 minus the root all over 2. It's kind of interesting. So you get this nested root idea. But it is an exact value and it will be equivalent to the original there. So kind of neat stuff. These do get a little bit weird and complicated. But the ones that you're going to see in my math lab, they don't usually repeatedly apply these things. They just do the first one. But I just thought I'd show you that these can be repeatedly applied to find values of many different angles. We can also use this cosine, either these cosine values, to now find the sine or the tangent. Once you have the cosine, you can pretty much hit all of these because the cosine is more powerful in these formulas. If you had the sine, you can still get the tangents, but I think you can work with the cosine a little bit more diversely. Okay.